Hello, my name is Reina. Thank you for visiting my channel. I'm sorry it took a while for me to get back on track. I've been thinking about my contents for a while. I want to start doing videos on real data sets and how to analyze them rather than doing videos on like how to do ggplot. There are so many YouTube videos out there that shows you how to do it. So rather than that, I want to show you how I think when I analyze data sets. Of course, if I feel like I need to do a few videos on, how-tos, then I will keep on doing it. But yes, for now, I want to try this way, so please bear with me. Thank you for your understanding. So today's video, we are answering a question: can we use publicly available FDA adverse event data to identify unusually reported drug safety signals? I am going to use this publicly available data set called FAERS. I think that's how you pronounce it anyways. Here we go. Oh, sorry. It was formerly called FDA Adverse Event Reporting System, FAERS, but now it's called AEMS, FDA Adverse Event Monitoring System. Okay, so basically here's a definition. Long story short, it is a database which has lots of adverse events reported. So, like any drug adverse events. So it collects information regarding adverse reactions of medications from healthcare professionals and others and releases them in text files every quarter yearly. So if I go down, this can be visited from US Food and Drug Administration website. Okay, if I go here, extract files. You can see these files. Here you can download all the files, and once you do download it, it's got a PDF file as well as all these text files. I'll show you an easier one. For example, this React 25 quarter. So this is 2025 third quarter adverse reactions that were reported. So this one has a list of primary ID, case ID, and the adverse reaction. And I think this one, it's mostly empty, but if I look at the, I'll go back. The PDF file, it's got a lot of really good information. Like it explains what each of the text files has. Yeah, sorry, React stands for reaction. I should have said that earlier, but that's okay. This drug recur action data. Okay, so it's when the event reappears upon re-administration of the drug. So anyway, I'll go into more details. But yeah, basically that's the reaction file. So it has case ID is pretty much like the patient, and primary ID is like each version of the case. So like if there's a follow-up for the same event, then there will be another primary ID for that follow-up. But case ID will be always one per case. And PT is, where did it go? Oh, here we go. Preferred term. So basically, like what happened, like the adverse event. Okay, and prepare for the next one because that's a lot more complicated. It's got a whole lot of information about the drug that caused the reaction. So primary ID, case ID. Primary ID, those are almost always in each text file, but the drug file has, a really, really detailed report on about the drug, like even like the expiry date of the drug, dose form, dose unit, dose amount, dose frequency. For today's video, I'm not going to go through all of that because it's irrelevant. So basically, I'll show you how to clean up the text files so it is aligned with our objectives. Yeah, and that's the demographics file, so that's even looks even more complicated. So a few reasons why I decided to use this data set. One, because I used to be a pharmacist, so it's a little bit easier for me. But also because it is a real life data set. So it's, it comes from real people that could either be healthcare professionals, so doctors or pharmacists, or it could be a consumer, so the person actually taking the medication that actually felt the adverse reaction. So it's pretty interesting. It has a lot of missing values and, it needs a lot of data cleaning. And very importantly, it is a spontaneous report, meaning that there will be a lot of errors and bias. Because a patient might be having more than one condition and might be taking multiple medications. So they might mistake underlying condition as an adverse effect of a medication, or there could be a double up. Like a doctor could submit the report as well as the patient without each other realizing. These are actually really important to recognize because, it is going to change how we approach this correctly. So the question, we're coming back to the question of, can we use publicly available FDA adverse event data to identify unusually reported drug safety signals? So what I'm saying is basically, can I find anything strange going on? Can I find something new? But it's such a broad, question. We're going to have to be a bit more specific here, so that we can visualize and analyze this data set. So if I break it down, it could be like, I want to find the most common adverse reaction in this data set and the drug that's causing the particular reaction. And then maybe we could just look into that drug. But the text files that I showed you before, here we go. I'm not going to show you this one. But, so these 3 files, these are the ones that I'm going to be using today. I just want to focus on these 3 only. There are other ones, report source file or therapy dates file. But I'm not going to look at those ones, just to keep things as simple as possible. So we will begin with data cleaning. Prepare yourselves because, like I said before, it's a very messy data set. So we will first of all load the required library and the data sets. Tidyverse, as I mentioned in my previous videos, has multiple libraries perfect for data cleaning. So make sure to check out my article on that as well. Link in the description. Okay, so I'll load this. I am looking at the reaction file first. So this read dlim is basically very similar to read CSV, but except because this is a text file, this reads the delimiter file. So with the delimiter, so in this case being a $sign, here we go. The delimiter is a $sign here. And the last part is empty for most of these. And the column names do exist at the top here, so make that true. And the trim WS, just in case, which removes white space, I believe. Okay, so I will load the data that has 1,535,133 observations. So that's in 3 months. But then again, like I said, there could be a lot of duplicates. But yeah, we will look into those. So for example, if we look at this one, the first 3 So that's one event, like one case. So yeah, one event. So pretty much one patient, you could say, already has 3 adverse effects. But we can't tell whether it's from 1 medication or 2 or 3 yet, because yeah, this is just the reaction text file. Like, look at this one. That's like, how many? 33 reactions for one event. Anyway, but from looking at this file, like, it looks like they were either able to select adverse reactions from a list or something, or someone fixed the, any spelling errors. Yeah, it looks like it's quite clean. So I don't think I need to worry too much about fixing characters. Okay. So this one finds any missing values. So if I load that, yeah, see the last part, the recurring of the adverse reaction. This has so many missing values, so I think I will just go ahead and delete it, which I have already written. So now that's 3 observations now, 3 columns. Then we remove duplicates, any rows that are exactly the same. Yeah, we will remove those. So, actually, we will have a look at the summary. So primary ID, case ID, those are recognized as numbers, but because they're IDs, like they are identifiers of each case, like each event or versions of event. So we will change them to characters. I just use this code here. Okay, so if I look at the summary again, those are characters now. So now we move on to the drug file. I am doing mostly the same thing as the reaction file. So I load the data. Okay, so let's have a look. Most of these, it's irrelevant. What I want to keep are the primary ID, the drug name. Prod AI is the active ingredient, the actual drug name, whereas drug name is the brand name. I will remove those unnecessary columns, so it's easier to just do select these 4 columns that I actually need. So here we go. And then actually I'll do this. Okay, so there's 37,089 missing, but I don't think that's big enough to worry about because there's 2 million observations and the drug name actually has 0 missing values anyway. So we'll leave that for now. And then next, remove duplicates. And then if I look at the summary, sorry, these codes are not in the right order. And then by looking at the summary again, the primary ID is in type numeric. So we will change that to character. And to do that, that's the mutate code. If you're not 100% sure what I did in these mutate codes, for the reaction file as well as here. Again, please have a look at one of my videos. I think it's the data cleaning video. And I'll put the link in the description again. Okay, so as I mentioned before, the primary ID is case version number. So for each case ID, if there's for example, a follow-up observation, then the version, the primary ID the number gets incremented. So 1 becomes 2 in the end. So this means that there could be multiple primary IDs for the same case. We don't like duplicates, so we will only use the latest primary ID as that's the most updated version as well. And to do that, apparently the most reliable way is to look at the demographics file. So the demographics file, here we go, has patient demographics. So it'll definitely only contain one primary ID. For this video, I am going to use this primary ID as a reference when combining these two other files later. Probably in the next video, because this video is getting so long just to do the data cleaning. Oh, and if you look at the PDF again, they have like a really nice mapping of different files. So yeah, the primary IDs, these are all related. So yeah, I'm going to use the demographics primary ID just as a reference. So as I was editing this video, I realized that the data cleaning of the demographics file is a lot more complicated than I thought, because there's also going to be a lot of duplicates. And how would we find out if these two cases are of the same person? Well, if we look at the demographics file, actually I might just load the data so it is easier for us to see. So a few useful information here. Obviously the primary ID, date of the event, but I'll go through it later, but there's a lot of missing values here, so I'm not sure. Here we go, that's a lot easier. Safety report version number, that's going to be not very useful. Initial follow-up, no. Date manufacturer first received initial information, that's going to be pretty useless in our case. Most of these are not so useful. Just for this video, I figured that the only useful columns are the primary ID, age, sex, the event date, and the country of the event happening. But because the date of the event, there are a lot of missing values. Pretty much the only useful things are age, the person's age, the gender, so sex, and yeah, the country of the event, which there probably could be so many 50-year-old males living in America. Like, how do we know that if we delete all these duplicates, how do we know if we accidentally deleted a different person? So I think the best thing to do here is, and please let me know if there are any better ways, but I think it is to combine all these three files and then deduplicate it. So there's also other factors to consider, such as the drugs they were taking or the adverse reaction they had. Okay, so for the data cleaning, I will just select these columns. All the other 20 variables will be unnecessary for this case. Okay, so I'll just show you the summary. Primary ID, that needs to be changed again to characters. In age, I also noticed that the maximum age is 24,743, which obviously is not right. Yeah, even here, like the event date here, the missing values is 250,000 out of 438,000, which is over half. In the country, I think it's, if I have a look, yeah. So it's pretty limited. CA, US, EU. So I might just use factors for the countries. So this code is just looking at how many rows have age over 100. Like this one is 247 years old. Anyway, I thought since there is only 108 observations, I thought I might just exclude ages over 120. So this code, I filtered the rows to only contain ages under 100 or under or equal to 120, or if the age is missing, I would still keep it just in case. Okay, and we delete all the rows that are exactly the same, which turned out to be none. And then I will mutate all these data types. Currently the event date is formatted like this with no, hyphens. So it's probably the easiest to use library called Lubridate. Lubridate uses this YMD format, which is, year, month, date without the hyphens. And changes it to, if I go mutate, so it changes to this date formatting with hyphens. Also, I forgot to mention, but the Lubridate package is in the tidyverse package as well. I will show you how I joined the datasets and a lot of different data visualization I did to analyze the data and what I found from those observations in the next video. Thank you so much for watching.